Okay, section 10.3, Pythagorean identities. Some of the stuff I'm about to talk about you already know. But I do need to get you back in the mood of the unit circle. So I'm going to just draw a simple sketch here of the unit circle. I'm going to draw an angle. And I'm going to try to get you to remember that if I were to drop this segment down here, that this x value of this point here, so here we have a point xy. So we have an x and we have a y. And the radius, because I'm telling you this is a unit circle, is 1. And so, the old Pythagorean theorem would say that from the picture I just drew, x squared plus y squared equals 1, which is good news. But we know that this is not just any old x, y. This is actually, we'll call this theta, that this is actually the cosine of theta, the sine of theta. I don't like the way I'm spacing this. Hold on a minute. Let me just fix this a little bit here. X, Y. Okay, so up here I'm just going to write that really that X is the cosine of theta, and really that Y is the sine of theta. So I can come over here, and in place of that X I can put in the cosine of theta squared, plus in place of that Y I can put in the sine of theta squared is equal to 1. And by the way, this really is 1 squared, but that's just 1. So that right there is your first Pythagorean identity. And it's normally written like this. Cos squared theta plus sine squared theta equals 1. It's just easier to write it that way. But you need to understand then that cos squared theta really means cosine of theta, the whole quantity, squared, plus sine squared theta means sine of theta, whatever that is, that whole quantity squared. So there you go, your first Pythagorean identity. Woohoo! Okay, so let's put it to work. Verify that the cos squared of pi over 3 plus sine squared pi over 3 actually does equal 1, because if it doesn't, then that identity is washed up. So I might suggest that you might remember this a little better if you turned that pi over 3 into an angle you can deal with. So 180 divided by 3 is 60. So this really is the cos of 60 squared plus the sine of, it's the same pi over 3, so it would be the sine of 60 squared. And the question is, does that equal 1? So, if you remember, my favorite, the sine of 30 is equal to a half. So that means that the sine of 60 can't be equal to a half. So this really is radical 3 over 2. And then this has to be a half, because it's kind of its partner in crime here. So now all I got to do is verify that when I take these two things and add them up, they add up to 1. So 1 over 2 times 1 over 2 is 1 over 4. Plus square root of 3 times square root of 3 is 3. And 2 times 2 is 4. And sure enough, if I take a fourth plus 3/4, I get myself 4/4. Keep putting little question marks here, and I think you would agree that 1 equals 1. So we have just proven that to be the case. Okay, so review. You've met these before and you need to know them, so if you need to stop the video to write them down, you might want to do that. These are called the reciprocal identities. And so really what you need to know, I've written the SOHCAHTOA stuff down, but what you really need to know are these relationships right here. That if I want to know what the cosec is, just take the reciprocal 1 over the sine. If I want to know that the secant of an angle is, take the reciprocal 1 over the cosine, and cotangent and tangent are reciprocals. These are not on the cheat sheet. You need to know them. You've met them before. Okay, the other thing that you've met before is what's called the quotient identities. Now, we might not have necessarily been calling them this back then, but the thing that we met sort of more was that the tangent of an angle, tan theta, is equal to the sine theta over cos theta. But from what we just talked about back here, since cotan and tangent are reciprocal functions, then it has to be true then that tangent, cotan, those are reciprocals, so then we should just flip sine over cos would be cos over sine. So this is another thing that must be in the brain. It is not on the cheat sheet. Which leads me to completing the Pythagorean identities. So as I said before, We already met this one. That's one of them. But there was actually two more, and I gotta admit, personally, I don't even really memorize these because I can recreate them so easily. So basically what I do is I just take this cosquared theta plus sine squared theta equals 1, and I divide all the way across by the cosine of cosquared theta. And so what ends up happening is anything divided by itself is 1. Since the sine theta over cos theta is tan theta, then sine squared theta over cos squared theta is tan squared theta. And since the reciprocal of cosine is secant, then the reciprocal of cos squared theta is sec squared theta. So there you go, number 2 Pythagorean identity. And then to get the last one, instead of dividing by cos, I'm just going to divide across by sine. So, cos over sine, as we just looked back here, cosine over sine is cotangent. Therefore, if I have cos squared theta over sine squared theta, I have cotan squared theta. Plus, anything divided by itself is 1. The reciprocal of sine theta is cosec. Therefore, the reciprocal of sine squared theta is cosec squared theta. So this is your last Pythagorean identity. So these three guys need to be in your brain also because they are not given to you on a cheat sheet, and there's just different problems where these relationships come in handy to find when you're given some piece of info to find some other pieces. So let's put one to work here. Or actually put more than one to work. If the cosine of theta is a third, theta is in quadrant 4, use identities to find the other 5 function values. So this whole thing about what quadrant we're hanging out in, remember, is just so that we make sure we put the right sign. So all students talk constantly, and we are going to be hanging out in quadrant 4. So basically, cosine is going to be the only thing that's positive. Now, if someone asks me to find all the other 5 function values, I usually do the easiest thing first, and I say, okay, if you're going to tell me the cos of theta is a third, then I'm going to tell you that the sec of theta is its reciprocal. So 1 over 3, flip it, 3 over 1. So the sec of theta is 3. And so that kind of gets me started, and it just feels like, oh, I could do that. So now, let's put sort of the most basic identity, Pythagorean identity to work here. So cos squared theta plus sine squared theta is equal to 1. So if I know that the cosine of theta is a third, that means I can put a third in here. So 1/3 squared plus sine squared theta equals 1. Don't be afraid, this is fractions. So 1 over 3 squared is 1/9 plus sine squared theta is equal to, I'm going to write this as 9/9 just to prepare for what I know I need to do. Subtract a 9th off of both sides, so I get 8/9. And then I'm going to take my square root here. So it turns out then that the sine of theta is going to be equal to radical 8 over square root of 9, which would be 3. And just to think about it over here and save a little space, radical 8 is 4 times 2, so that would be 2 radical 2. So I have 2 radical 2, but I need to remember I'm in quadrant 4, so it needs to be negative. 2 down. Okay, from now it's like a little puzzle. So I've got 2 of them. So why not go to the reciprocal of sine, which would be cosec. So cosec then is just going to be the reciprocal, so I'm going to take 3 over 2 radical 2. But I want to clean up that radical, and I'm going to go radical 2 over radical 2. So I get 3 radical 2 all over. Square root of 2 times square root of 2 is 2, and 2 times 2 is 4. And I need to be careful because the reciprocal functions have the same sign as in SIGN. So this guy needs to be negative also. Okay, 3 down, 2 to go. So now let's put one of our quotient identities to work and figure out what the tangent is. So if you recall, the tan of theta is equal to the sine of theta over the cosine of theta. So the sine of theta is 2 radical 2 over 3 right here. all over the cos of theta, and so the cosine of theta, if I go back up to the get-go here, is 1/3 that they gave me in the problem. So I'm going to take 2 radical 2 over 3 and divide that by 1/3, which in the end is 2 radical 2 over 3 times 3 over 1, which is 2 radical 2. And now I need to check my sign, as in S-I-G-N, and I realize that I am in quadrant 4, so tangent's going to be negative. So the tangent of theta then is negative 2 radical 2. Okay, one left, and the last one is the cotangent, which is just the reciprocal of tangent. So the cotan of theta is equal to 1 over 2 radical 2, and it's still going to be negative also. And I'm just going to multiply by radical 2 over radical 2, and I get negative radical 2 all over radical 2 times radical 2 is 2, and 2 times 2 is 4. So the cotan of theta then is negative radical 2 over 4. Okay, one last thing, and that is just using these reciprocals and different identities to rewrite something. So if we're asked to rewrite tan theta plus cotan theta in terms of sine theta and cos theta, and write the sum as a single fraction in simplest form. Really, what this type of problem is getting at is, can you do some subbing in of things? As in, knowing that tan theta is the same as sine theta over cos theta, and knowing that cotangent of theta is the same as cos theta over sine theta. Now, it would be nice if right now you could say I'm done with this thing, but you can't because it says to write it as a single fraction. So, to join forces, I need to multiply cos theta times sine theta. So, in order for cos theta to join up with sine theta, I need to multiply sine theta times sine theta. And in order for cos theta to get on top of cos theta and sine theta, I need to multiply cos theta times cos theta. So, in the end, I end up with sine squared theta plus cos squared theta all over cos theta sine theta. And if you go back to that first Pythagorean identity I taught you, turns out that sine squared theta plus cos squared theta is equal to 1. So this is the end of the story. I've done what the problem has asked me to do. So now you should go to MathXL for school, do the online practice, and see how you do.